Back on the Carver M400, this is not the T version, this is just the M400. The triac here came loose from this. It's press fit in. So I went around it with a screwdriver, put little dimples in it, kind of deforming it. Hopefully I can press fit it back in tightly. So probably take a socket or something that fits around it and see if I can knock that thing back in there. Okay, got it back in there. I found the socket that fits around it and just beat on it. Took a hammer and tapped it back in place and push on it. It will not come out. It's tight. I have this 100 ohm resistor. Yep, I triggered it. So trigger's on. I already tried the opposite direction and it triggered on, so still works after all the beating on it. So solder this thing back in. Okay, I have the new capacitors all installed here. And I have to put the high rail caps on. I think I'll solder these wires in first, because the caps sticking out might be in the way. Yeah, these are pretty long though. Let's see, this is the fuse, thermistor. This is the return for the ground, or the output, so I think that goes down here. So yeah, I think I'll do that first and then put the caps in. Next I'll have to leave this board loose because the output boards plug into this connector. The other output board plugs on top of that still. So I have to leave this loose because I have to have room for the connectors to move vertically, because the transistor, you know, the little connectors, the mounts push into these holes in the metal work here, so I have to have that freedom of movement before I can tighten this thing in. So yeah, they didn't make this thing easy to service, especially if you have to power it up to find a problem and then tear it down again, like I do with the other amp with that high rail side that's not working. Hopefully I don't have that on this one. I mean, I tested all the components. I don't see any issue. But, we'll just have to try it and find out. Okay, I have this board just sitting loose in here. Transformer's just sitting loose, because I got to get this audio board, amplifier board. This is the bottom one. It has the pins on both sides. I got to get this white wire. Wherever it is, there's a right there where that little hole is. I got to get that up in there and solder it, get that plugged in, and then the red wire on the top board. Okay, got the boards in there. Now I got to get all of those drivers and thermal sense. That's kind of a pain down under there. I have to keep the transformer out of the way. Get to that one and that thermal sense. Gee, I hope this thing works. It's a lot too finagling to get this thing back together and apart and worked on and all that good stuff. Well, I had to pull this cap out again because I needed to access the socket. They wouldn't go into the holes in the aluminum. I had to kind of push up with my thumb to get it to go into the hole. See how these fit into the hole of the aluminum heat sink. They all have to do that. So what I'm doing is I'm just putting the outer transistors in. That acts kind of as a kind of holds the board into position, so I can screw the driver transistors and the thermal sense transistors down before I can move on. You don't want to force or bend anything when you're doing this. That's why I want to make sure it all fits in smoothly. I got the grease-o-matic transistors all back in. Might as well just put them all in. Doesn't really matter. These screws with the insulators, the little insulating washer there, that's for the TO220 drivers. I'm glad I have this little tool kit with the extension. I can get it back in there. Screw this bolt on there. And these are for the thermal sense transistors in the middle there. They don't have the isolating washer, so yeah. All back together again. Got the capacitors in, make sure they're tight. I found that missing standoff for the transformer, that's nice. Okay, got the triac in and tightened, the board's tightened. Input jacks are tightened. Drivers on both boards. Thermal sense in and tightened. All transistors are in their correct place with their mica washers. They're all tightened. I soldered all the wires. Had to take out red on top, white on bottom. I left my little tags on. No extra parts left over. The moment of truth. Will this thing work? After all this work, it had better work. We got our condom on. We're YouTube safe here. We don't want to get that copyright strike. It's working fine. I've actually run it for a couple hours. Voltage regulator circuit seems to be working. I don't know if you can hear it. It sounds like a vertical output circuit on a CRT television. I don't know if you can hear that or not. So yeah, I'm going to hook it up to the scope because with these amps, with the more complex design with the 3 rails, you don't know if they're actually all working unless you test them. So that's what I have to do here. I'm going to test a few things before I give it a clean bill of health. Okay, we're checking the triac here. I'm on the secondary of the transformer, so you get a little overshoot. So that's why you're seeing that. But when I put a load on it, you can see these expand a little bit as it needs to increase the power. So it increases the triggering, makes it earlier in the waveform. So yeah, that seems to be working. They say to keep the switch in the down position for smooth triggering of the triac. It may be sort of random in the up position. They say that's normal for this supply. So yeah, everything seems to be working okay. So the voltages I'm getting with the switch in the down position is 23 on the low rail, the mid rail is 47, the high rail is 75. When you change the position of the switch into the upper position, it lowers the voltage just a little bit, so it makes it compatible with lower impedance loads. They did away with that switch on later versions of the amp. However, I would just keep it in the upper position. It's a little easier on the electronics, I think. A little bit lower voltage, unless you need maximum power out of the thing. But yeah, most listening, you really don't need it cranked up. Okay, so now I'm going to hook up and check the power of this thing. Okay, I got the load resistors hooked up, and we'll crank it up into clipping. There's clipping, so I'll have to get a measurement pretty quick. It died. It stopped. I think I blew the fuse, I hope. Please be the fuse. 8 amps? Really? It drew that much? You just kind of shut down. Here, let's set this camera down here. Let's see what blew. This fuse is warm. Yeah, I can see. Well, so much for my 8 amp fuse idea. That went open. So I guess I need to grab another fuse. Here's a 12 amp. Pop that in there and redo my test here. Okay. Let's try the test again. $42 volts. Now we'll say 41.5. That's what I saw there on the screen. These things get hot quick. So let's do some calculation here. See what the what did I say, 41.5, and we'll square that, divide it by our 8 ohm load. 215 watts, both channels driven. Yeah, this little cube thing has got a little power. Now, I'm going to test the other channel, because if you remember on the 400T, if you watch my videos, that other channel, the high rail, wasn't working on the negative side. So let's test the other channel and see what happens. Yes! Both channels are fully working. Okay, so now I got to get this cover back on. I'm just looking around it, make sure all the wires are routed right and screws are tight. I remove the tape. I put that over the heatsink grease to keep it in good shape, because yeah, it gets everywhere when you touch the thing. Plus it'll save me from having to use very much of mine. And I'll clean this up a little bit, and yeah, put this thing back together, be done with it. Okay, it's all back together again. No extra screws, no missing screws. It's in pretty good shape. Got a little bit of scratching on it, but yeah, what are you gonna do? Well, I'll plug in this wonderful Radio Shack high quality cable here. Look at this. Ooh, gold plated. Got the little tri-grippy dots there. That means something, doesn't it? That improves the audio. These fat jacks. So when the jacks are close together on the back, they barely fit because they're so fat. And you got to squeeze all that audio through there. Look at these thick cables. I mean, this is quality all the way here. So the meter is working. I don't have to battle with that. So I'm going to break this thing in listening to some AC/DC. Quick recap of what I did to this thing. So with this amp I had to replace all the power supply filter caps. And I went ahead and replaced some on the amp board as well. And there was another one a small one on the power supply board that was bad. So there was 15 electrolytic caps in all. I tested in circuit all the silicon using the meter. Didn't see anything wrong there. Inspected the resistors and solder joints. All that looked good. Straightened the bent chassis. I fixed that triac. It came off its mounting ring, so I had to press fit it back in. Put all the guts back in the chassis there, run some tests, and we're all good. So yeah, this is the M400. What I need to do is get that M400T and fix that. If you remember, one of the rails was not working. The high rail on the negative side of one channel was not working. Of course, I have to tear it all back down again the way it's set up. So that's kind of annoying. But yeah, that'll be a future video. But for now, we'll wrap this one up. Thanks for watching and the support and all that good stuff. Catch you on the next one.